Can you hear me? Hello, can you hear me? Please reply in the chat if you can hear me. Yeah, good evening everyone. Can you hear me? Okay, fine. Let's start. Now question arises, what do you understand by the AC analysis? Then only we will move to doing the AC analysis in a circuit. It is the AC analysis is the steady state behavior of circuit when we apply sinusoidal input. Right? So what are the sinusoidal inputs? Your Vt is equal to Am cos omega t, or Vt is equal to Am sin omega t. Okay, in general these are the sinusoidal inputs, right? So from the basic you know how to draw the cos and sine. This Am is called the amplitude or peak value of the sinusoidal wave. The one complete cycle is called the time period of the wave. Right? Then how many time period in 1 second is called the frequency of the wave. So it is reciprocal of the time period. Then angular frequency is unit has hertz. The time period has the unit of second, and angular frequency omega is 2 pi f and its unit is radian per second. Okay, same way this is a sine omega t, Am sin omega t. Same way you can find for the cos omega t. Okay, cos omega t starts from 0, that is the maximum value at 0, and then goes like same. and you know that sine and cos are different only by a phase shift of 90°. Then move to the what is delay and what is lagging wave and what is the leading wave. So one thing I want to tell you that the reference can be cos or sine. When you do the phasor analysis, anyone can do, you take as a reference. There is no difference. So once you choose a reference, so you need to stick to it. For example, suppose they have been given 130°. Let's say V in a phasor notation has been given. So in instantaneous notation, you can write 100 sin omega t plus 30°, or Vt is equal to 100 cos omega t plus 30°. Any one you can choose for the instantaneous value, and that will not have any problem. But once you have chosen, or you can say logged it, then you have to do analysis assuming that reference only. Okay, first you choose any one of it, and then you can log it for the further analysis of the circuit, right? What is the leading wave, what is the and lagging wave? I will do with respect to sine. Okay, let's say reference is your Vt, which is equal to Vm sin omega t. Hi Mohammed, after a long time I am seeing you. Okay, so I want to say, what is this form of wave? Right? So you see that the reference you have to take from t equal to 0 for this Vt, right? So I can write this, let's say this different time lag, it is a time lag, let's say it is t0. So I can write V1t, amplitude remains same, frequency remains same, so sine omega t, only the lagged by time t0. So how to convert it to that is the degree or radian or angle, because this is the omega t is the radian, so you multiply omega with t0, that will give you the theta 0. So minus omega t0, and finally Vm sine omega t minus theta 0. That means okay, that's fine Mohammed, please follow the class, you learn many things. Okay, you see that this wave v1 v1t lags by Vt by an angle of theta naught degree. So we say that it is a lagging wave. Same way you can show a leading wave with respect to reference sine function. this is your T, this is a, let's say, V2T. Okay, this is 0, and this distance, or you can say this time interval is 0. So you can easily write V2T is equal to, amplitude remains same, Vm sin omega t plus theta naught. What is the theta naught? Theta naught is equal to omega t naught. So we can say V2T wave leads Vt by an angle of theta naught degree. Clear? So there should not be any confusion for leading wave and lagging wave. Later on we will see how we represent in this is the instantaneous equation. When we convert into the phasor notation, how we represent in a two-dimensional plane. So before moving to the more things, I want to have discussion about the notation for the AC wave or AC signal. Notation. So Vt, already we are discussing, this is the called instantaneous value. Instantaneous value of the wave. Instantaneous means instant value we can find out by this notation, like V2T, Vm sin omega t. So it is denoted denoted by the small v into t. Then Vm, it is the amplitude or peak value of the wave. Amplitude or peak value of the wave. Then VDC or V average, VDC or VAVE, V average, it's called the average value of the wave. Then VRMS or V effective, this is called the RMS value, RMS or effective, or another term you know, the heating value. Heating value of wave. That determines the normally people confuse with the average value. That is the average value will heat a coil, the heat produced or power produced, but it's actually same है heat energy. The energy how you calculate the energy for a AC? Obviously from the RMS value. From that you should understand that heating value is the RMS value. Now we will calculate some of the measures for the AC, like average value, root mean square value. How we going to calculate? First is the average value. VDC. How it is defined? VDC is equal to 1 upon T integration over a period VT dt. Okay, VT dt. Let us calculate for the sinusoidal wave, that is the average value. Average value we can calculate for the any signal, whether it is a square wave, whether it is a triangular wave, whether it is a sinusoidal wave. So let us calculate for the, let's Vt is your sinusoidal wave, whether cos t or sin t. Let's say it is your peak value. Let me designate like Vm or Vp, anything you can put it. Vm sin or cos, no issue. Okay, Vm sin omega t. So VDC of this value is the 1 upon t over a period. I can take minus t by 2 to t by 2 or 0 to t, anything you can take. Then Vm sin omega t dt, right? So Vm upon t, see here, integration of sin omega t with respect to dt. So very simple integration, 1 upon omega minus cos omega t minus t by 2 to t by 2. So Vm t omega, what is omega? 2 pi upon t, then minus cos omega is the 2 pi upon t into t by 2, then plus minus na, okay, minus plus, okay, plus cos 2 pi t, because cos of minus theta is the cos theta, so that's why it is coming the cos of 2 pi into t by 2. So whatever the value here, Vm upon 2 pi, what is this value? Tt cancel, cos of pi minus 1, so minus of minus 1 plus here minus 1, so you see that 0. From wave itself, intuitively you can check. This is your sine. Okay, we are doing integrating over a period. What do you mean by period? I have many times repeated for a integration, when I do the integration over a period, that means up to here you doing the integration, that means area, this positive area, let's say P. So this will be minus P, this area. So P plus minus P is equal to 0. Intuitively, qualitatively, you can check it for a wave. Now come to the RMS value, effective value or heating value. Okay. So RMS, hopefully you know, it is the root mean square RMS value. So V RMS square is equal to 1 upon T integration over a period. Okay, V square T dt. we are dealing with the all the real signal in the network theory. Okay, so this definition changes in the when you study the signal and system, it will be changing to the 1 upon t over a period Vt magnitude square dt. Okay, because there will be dealing with the all type of signal, whether it is a deterministic signal or probabilistic signal. In the deterministic signal, whether it is a real signal or imaginary signal, that's why we take the magnitude. And in a probability signal, it is altogether different way to find the average value of a random variable, a random signal, or effect, that is a mean square value, then your variance, all this comes into play. So for time being, we just concentrate on the one subject, that is the network theory. So we will dealing with the all sort of real signals, right? So let us calculate the RMS value of sinusoidal wave. Let's say this time we will calculate the cos or sines will have the same RMS value because both qualified as a sinusoidal signal, Vm sin omega t. So as per the definition, Vrms square is equal to 1 upon t integration minus t by 2 to t by 2 v square t. V square is your Vm square sin square omega t dt. So we can take out Vm square, then see here, the signal is an even signal. Sin square omega t is an even signal, so I can write multiply 2 and integration from 0 to t by t sin square omega t dt. So 2 Vm square upon t. So if you know the direct formula, otherwise you know that cos 2 theta is equal to 2 sin square theta, na? Right, 1 minus sin square theta. Okay, 1 minus 2 sin square theta, right? Yeah, 1 minus 2 sin square theta. So sin square theta will be the cos 2 theta minus 1, right? So I'll write 0 to t by 2 half 1 minus cos 2 omega t dt. Okay, 1 minus cos 2 omega t dt. So Vm square upon t. So this will be the Vm square upon t. Okay, and the integration of this is the t, and the integration of 2 omega, that is the minus 1 upon 2 omega sin 2 omega 2 pi upon t in, okay, 2 pi upon t 0 to t by 2. When you see here Vm square upon t, this is t by 2. You see here, when you put the t by 2 here, t by 2 cancel, t cancel, 1 2 cancel, so remain 2 pi. Sin 2 pi is 0 and sin 0 also 0. This is 0. You can say also intuitively, this is a only sinusoidal with a twice frequency. So its average value is simply 0. So you find that this is Vm square upon 2. So Vrms is equal to Vm upon root 2. Right? Let us move to the how we define the qualityness of one wave. Qualityness of an wave. Okay. So I'll give you the uh, uh, task so that you should do. I can do each and everything, but you should do. What is the RMS and average values of half wave rectified signal or wave? That means many of you know the answer, but I want you should do the drill. Okay, so that why we should practice, because that will eliminate the any you can say the conceptual shortcomings or the what we call the silly mistakes. Many people say that I have done the silly mistakes, but silly mistakes comes from lack of practice. That is a proven thing I have seen in my life. Okay, so this is the Vm and this is the T, and obviously steady state means it extend here, so you need to do find the average value. The answer is VDC is Vm upon pi and Vrms is equal to Vm upon 2. You need to prove it, you need to find, right? Similarly, average and RMS value of full wave. Full wave rectified wave. How it looks, full wave rectified wave. I must go for the drawing competition. T by 2, T like that, minus T by 2. So it is a task, you should find the VDC is the 2 Vm upon pi, okay, and Vrms is equal to same as the, because RMS value does not change as a sinusoidal wave. Okay, now the qualityness of, or you can say the quality of a waves generated by a source. Suppose you are generating a sinusoidal wave. Okay, how to measure the that sinusoidal is very high quality, that it matches exactly with the AM sin omega t or AM cos omega t. For that, first quality factors, or you can say quality we check is the form factor of the wave. Form factor wave, that is FF, form factor of the wave, and it is defined as RMS value upon average value. Okay, for pure AC, for sinusoidal, not pure AC. For sinusoidal, FF is equal to RMS value Vm upon root 2, that is the average value of full wave rectified wave. Full wave, because the average value of this sinusoidal will be 0 na. Full wave rectified wave. Full wave rectified wave. So Vm to Vm upon pi, which is pi upon 2 root 2, and which gives you 1.11. Okay, so when when an inverter, you are buying an inverter, so you will see when you look at this, how, what is that is square wave inverter or sinusoidal inverter. They claim that it is a pure sinusoidal wave. You need to check their data sheet. What is the form factor, what is the crest factor, they will clearly mention. If form factor like 1.08, that means it is almost imitating like a sinusoidal wave, not exactly sinusoidal wave, so you need to check. Similarly, another one is the crest factor or peak factor. This is the peak value of an RMS value. Peak value upon RMS value. And for sinusoidal, CF is equal to peak value Vm, RMS value Vm upon root 2, which gives you the root 2, which is 1.414. Okay. So like inverter, you are buying an inverter, they will clearly mention the what is the output they are providing. Is it clear, everyone? Harsh and Saurav, Gansika Sharma, are you getting it? Yeah, बहुत बढ़िया. Keep learning. Okay. Let us. You need to when you are attending the class, you should have a scribble pad with you or a notebook with you. Okay, so that parallelly will do. Okay, that's good. Okay. Let me draw correctly, if I could. There's a asymmetrical square wave has been given, Vt. Okay, this is 4, this is -2, this is your 1, this is 2, t, the -1. I am interested in calculate the DC value of this wave and RMS value of this wave. DC value and RMS value of this wave. Anyone? Very simple. Yeah, I understand this is a delay, so I should not know. BDC is equal to 1 upon T integration over a period Vt dt. Okay. So here 1 upon T. What is this? Area under over a period. So area is the 4 into 1 plus minus 2 into 1. That is 1 volt. Good. Average value is the 1 volt. So this way you can quickly, if you know this, that's the integrations is the represents the area. Okay. So this is the application of integrations. Now move to the RMS value. One upon T integration over period V square T dt. 1 upon 2, 1 upon 2, you see this 0 to 1, when that is the 0 to 1, you have V square T, the amplitude is the 4, that is the 4 square dt, and plus 1 to 2 minus 2 square dt. So 16 into 1 plus 4 into 1. So 16 plus 4, 20 upon 2, 10. And the VRMS is equal to root 10, something like 3.16. Use a calculator if you have any doubt. Don't assume anything. Here, any doubt? Okay. Is it clear? Okay, fine. Now phasor representation. So in phasor representations, okay, let's say you have been given Vt is equal to, let's say V1t equal to Vm. So reference I will take the cos omega t. V2t Vm by 2 cos omega t plus 30 degree. V3t is equal to let's say Vm upon 4 cos omega t minus 60 degree. Okay, I want to represent in the phasor notations. So in the phasor notations, we'll use the capital V, V1 capital V2, and we'll drop the T So I can write V1 is equal to Vm angle exponential representation. This is called the exponential representations, that is 0 degree. Or I can write Vm, okay, Vm e raised to the power j 0 degree. Okay, is exponential, both are exponential representations. And another representation is the Vm cos 0 degree plus j sin 0 degree. This is called the rectangular representations. Okay, this is the exponential representation. All these are phasor representations. That is phasor in different form. This is the rectangular, and we use here Euler's identity. E raised to the power j theta is equal to cos theta plus j sin theta. Many times it will be used in every subject, whether it is a signal, whether it is a your machine, whether it is a communications, you will be whether it is a your electromagnetic theory. So similarly, I can use sorry, I can write V2 Vm upon 2 angle 30 degree, or Vm e raised to the power j 30. These are the exponential representations, and in Cartesian representation, Vm cos 30 degree plus j sin 30 degree, which is Vm root 2 by 3 plus j half. Similarly, V3 I can represent Vm upon 4 angle minus 60 degree, or Vm upon 4 e raised to the power minus j 60. All these are same, that's why I am using the equal sign. Don't be confused between the rectangular representations and exponential representation. For cos of minus 60 degree plus minus j sin of 60 degree, that is Vm upon 4 cos 60 degree is the half minus root 3 by 2 j root 3 by 2. Clear? Now come to the phasor diagram. Before that, I need to some about the complex plane, something about the complex plane, so that you will not forget the, or you will not have the confusion. This is called the first quadrant. Okay, this is up to 90 degree, right? Any point, see the nothing, it is simply a you will draw and the angle. For example, any voltage, let's say V1, but V1 was not exactly V2. The theta is 30 degree. This axis represent 0 degree, real. This is the imaginary 90 degree, or 0 degree 90 degree. This represents the j square degree. Okay, what is the j square? -1. -1 means 180 degree. Then this is your j to the power q, which is minus j. J, you know, j is the root over of -1. Okay, yes, cos 30 root 3. Yes, okay, good. Root 3 by 2, right? Root 3 by 2. Correct. This is that I did mistake. Rest, okay. Okay, this is your axis, 0 real axis 0 degree, then 90 degree is the j axis, perpendicular axis, minus j square is the j square axis is the 180 degree, j q axis is the j to the power q is the minus j, the minus 90 degree or 270 degree, not an issue. Okay, always remember any phasor angle always lies between the greater than yeah, greater than minus 180 degree, less or equal to 180 degree. You need to represent in between any phase angle, so that you can easily represent, because it covers whole space of the complex plane. So in this case, previously we have V1, V2, V3. Okay, 0 degree, 30 degree, minus 60 degree. So I want to represent in the phasor diagram. As you know that angle is always measured in clockwise direct anti-clockwise, sorry, angle is always measured in anti-clockwise direction from real axis. This is the real axis, this is the imaginary axis. J axis minus j axis this side, and this is a real axis, positive real axis, positive negative. So angle is a very important point. Okay, angle, many students don't know how to measure the angle, how to measure the angle of a phasor. So angle is always measured. Thank you, Dhrugesh. Angle is always measured from positive real axis. So my V1 I will represent 0 degree and the phasor, and that phasor will represent the value, length of this phasor will be proportional to the values. For example, Vm, so this length represents Vm. So just think about a vector, right? Just think about a vector. What we do in the what we see the vectors, angle, a angle, magnitude and direction. So same way, this is the magnitude, the length of this phasor is the Vm, and direction is your angle. Direction will be represented by angle only, na? So this phasor is your V1. Okay, this length is your Vm. Clear? Now we will represent V2. V2 is the half of this Vm by 2, but angle is 30 degree. This is your V2 and 30 degree. Right? Now V3. What is the V3? V3 is the minus 60 degree, but Vm upon 4. That is further the 4. It is divided by the 4. 1/4 of the V1 or 1/2 of the V2, and but angle is negative 60 degree. This is your V3. Now question arises, what is the angle between, what is the phase difference between the V2 and V3, and who is leading, whether V2 is leading or V3 is leading? What is the phase difference between V2 and V3, and which one is leading? Leading or lagging? By one is leading means other one will be lagging. Okay, can anyone say? Simply phase difference will be the measure the angle between the two vectors or two phasor. So you can easily see the phase difference between the V2 and V3 is the 60 plus 9 30, that is the 90 degree, with V2 leads V3. Yeah, is it clear? Let's say you have been given reference, your reference Vt is equal to Vm cos omega t, right? Vm cos omega t. So I can represent V is equal to Vm 0. Now at some other part of the network you observe, that is Vm upon 3 sin omega t plus 30 degree. So then what is the V1 in phasor notation? V1 in phasor notation. What is the V1 in phasor notation? So start doing, you should strive to do this with the looking at the reference. Reference, you should have a cos term here. Okay, so I'll start here. V1 can be written as Vm upon 3, okay, Vm upon 3 cos omega t, then plus 30 degree minus 90, because if I consider whole as the theta, we know that cos of theta minus 90 or cos of 90 minus theta same na, because cos of is the sin theta, right? So the property of trigonometry should be thorough. Okay, that is a task for you. Please revise the trigonometric this conversion from any standard intermediate book. So cos omega t minus 60 degree. So your V1 is Vm upon 3 angle minus 60 degree. Okay. So in some books you will find that they are representing the phasor as a RMS value, right? But we will stick to only one convention, that is the representing the representing phasor in the peak value. Because when you will study the electromagnetic theory, there also they will be using the, for phasor notation they are using the peak value. So we will stick to the peak value only. Okay. And in the GATE exam or any exam, the question will, any standard exam I am to say, the question will be framed, and whatever the things required they will be give you the in clear writing. They will mention whether that what this represent RMS value or peak value. So for that you need not to worry about that. Is it clear? So you can do easily. So after discussing about the phasor notation, okay, we'll move to the actual element, how they behaves. First we'll do the resistor. You have a resistors of value R, you connect a source which is Vt is equal to Vm cos omega. So I'll consider only cos omega t, Vm cos omega t. Okay. So what will the it? So I of t is equal to V by R. So Vm upon R cos omega t. So in phasor notations, this V equal to Vm 0 and I is equal to Vm upon R 0. So there is no phase difference between the voltage and current for a pure resistor. So in phasor notation I can write, because we will not be doing the analysis in this instantaneous value. So in phasor notations I will write, this is your V equal to Vm 0 degree and this is R and this is your I. So in phasor notations. Now come to the inductor. Once we do the analysis for the single element or pure elements, we will jump up to the their combination, series or parallel combination. Inductor. So IT is equal to Im cos omega t. We need to find the Vt. This is L. We know from the basic equation, Vt is equal to L d of it dt. So put the values. So L d upon dt I am cos omega t. So I got L I am omega sin omega t, right? And ultimately L I am omega cos of omega t sin omega t, sorry ये नेगेटिव है ना, डिफरेंशिएशन ऑफ cos omega t is a negative, so cos of omega t plus 90, same thing, cos 90 plus theta minus sin theta. So in phasor notation I'll write, I is equal to I am 0 degree and V is equal to L I am omega 90 degree. What is this 90 degree? So L omega I am cos 90 plus j sin 90, cos 90 plus j sin 90, which is j. So j omega L into Im. So you see that voltage, and we see that in the resistors, in a pure resistors, this is your V and this is your I for pure resistors. But what we see here for pure inductor, the voltage is, you see that voltage is 90 degree ahead of current. If this is your current I, voltage is 90 degree ahead, right? That means in a pure inductor, voltage leads current by 90 degree. So phasor notation diagram, I can write like this. My inductor has been converted into the j omega L. Okay, so this is your V and this is your I. Whenever you see an inductor, just write the impedance as the j omega L. You can clearly see V equal to j omega L into I, or I equal to V upon j omega L. So I will not go for the again deriving all these things. For capacitors I will write that directly, and I left it a task for you. Capacitor in a phasor notations, same basic equation you can do, and you should prove that capacitor will be behave like this. Whenever you are a capacitors, this will be impedance filled by the impedance, or you can say impedance of the pure capacitor is the 1 upon j omega c. Omega L here called the, many times they will ask what is the omega L. Omega L is called the inductive reactance. And 1 upon omega c is called the capacitive reactance. Right? Let us summarize. in an AC environment, steady state AC environment, I am discussing not transient AC analysis, it's a steady state AC analysis as I have told in the beginning. A resistor remains resistor in the circuit. A inductor is converted into the J omega L in the circuit, and then capacitors converted into the 1 upon J omega C. If you know these together with the phasor representation, then I think you know everything of the AC analysis together with the phasor representations. Let us do some drill. Okay. I know. I say that I know theta as the tan inverse 5 by 4. I have given you the theta. You need to represent angle of these phases. These phasor. Angle of this phasor. This is very clear. So whenever you have any doubt, just draw a complex plane and mark the point 4 plus J5. This is your real is the 4. This is J5 minus J5 minus 4. So this is your, let's say, A, point B, point C, point D. This is your point A. This is your point B. This is your point C, and this is your point D. So this angle is the theta. Already I have given the tan inverse 5 by 4. This angle, see here, this angle is the, this either you measure this 90 plus tan inverse 4 upon 5 or 180 minus this angle you know theta. So this angle for C, for A angle is theta, A angle is theta, B, okay, we'll find out, C, which one? C, this one, na? C is the, we see that 180 minus theta, 180 minus theta, B, C, D. Okay, B, what is the B angle of this? You see here, this angle, I have told you angle should be between, the theta should be between 180 degree minus 180 degree, greater than minus 1 degree and less than 180 degree. So measure from this axis, because it is a greater than 180 degree, so I have to represent in the negative. So this is your 90, either 90 or tan inverse minus 90 plus tan inverse 4 upon 5, because I have given you the theta this, so 180 minus 180 plus minus B na, minus 180 plus this angle is the tan inverse 5 upon 4, that is the theta. And what is the angle of D? Simply minus theta, this angle. First A, how A, the negative, okay, you have no, the B I can say not correct representations, okay. So B, yeah, rest all are fine. Okay. So please practice as much as you can. So these are the called the, if you don't study these will make the silly mistake in the exam. Just a reminder to you. Okay, there you know all the concept of the AC analysis, but you are weak at the representing the angle. This year also that angle they have been asked the complex variable, complex exponential. Many of good guys are that is those who are good at network theory or mathematics, they have also did the mistakes. So please be thorough in the complex numbers and complex representations in the complex plane. Yeah, D is a negative, right? Okay, I hope you have learned many things from today's class, that is many fundamental things, and please practice again and again. I am telling you, success is not that easy. Okay, you have to sacrifice many things, you have to break your comfort zone, you have to live like a ascetic, like a sadhu type आपको जीना पड़ता है, then only success आता है. ठीक है, because you that is enjoyment and your preparation can't go parallel actually. Okay, you understand what I mean actually, because learning or study requires a lot of concentrations. Okay, lot of concentrations. You cannot study with your mobile on these days. You have Instagram, you have Facebook, you have Discord, you have all the WhatsApp, Telegram, then what not I can say. So, every minute or every in every 15 minutes you have a message for you. So switch off it, because don't expect that Prime Minister Narendra Modi would call you, okay, in a day. So don't expect that. So for betterment of your career, then you can switch off during the preparation. There are a lot of distractions you have, and restrict your YouTube also. That is a pure I can say the addiction. Your Facebook these days, okay, we don't use the Facebook, but YouTube is going to be a big addiction nowadays. It's more than drugs, heroin, or like ganja, like the things. So please avoid the YouTube. Lot of motivators, you will see that they will be motivating you what to do, what not to do in the GATE exam, but nothing they will be imparting the anything for your value addition. So whether you should know, everyone is coming how to read, how to write but what to write, nobody is telling. So be aware of that. Don't kill your time, learn, add values to your preparation, add values to, so that you want to see yourself in the next year after the GATE 2024. You want to see yourself in the IIC or IIT, and you know these days lot of demand from the AI and VLSI. Don't think about the recession is coming and a lot of layoffs going on. These will come and go, and ultimately when the times comes, you must secure a seat in the reputed institute. That should be motto. For that you need to, whatever sacrifice you want to do for 1 year, because total productive life or useful life of a human being, if you take these days, is 80 years. If 1 year, 2 years you sacrifice for your betterment, nothing you are going to lose. Just think of it. Out of 80 years, you are engineers, you are science graduates. You just think how less is the 2 years, 3 years out of 80 years of your useful life. It's a negligible. So why there is a always the rush that if I don't enjoy for 2 years, my life will be hell, like that. Nothing will be that sort of thing. So put your best efforts. All the best for your preparations. See you in the next class. Thank you. Good night.